Well, hey everybody, Mr. Reeves back with you, and today we're looking at some IXL practice skills. So we are still working our way through 7th grade math skills, and we are still on expressions. So we're down here on expressions and properties, and we're going to first be looking at skill R14, adding and subtracting linear expressions. All right, so hopefully you've done all of the prep work, watched the videos, and done the practice, so you remember what a like term is. All right, so let's just do a quick reminder of what a like term is. Remember, terms are parts of expressions, so 10s is a term, and 9s is a term. Remember, the s's are called variables, and the 10 and the 9 are called coefficients, right? So this would be a two-term expression. The first term would be 10s, the second term would be 9s, okay? But now we're talking about simplifying expressions. Simplifying expressions means to take them and, well, do what it says, simplify it, write it in a shorter way. If I gave you the expression 1 plus 2 and I asked you to simplify it, I hope you would say 3. You'll notice 3 is more simplified than 1 plus 2. Most of the time, after you simplify, it's going to look shorter. It's more compressed. Okay? So like terms are terms with the same variable, or sometimes it might have more than one variable, to the same power, or sometimes it might have more than one power with the more than one variable. All right? So in other words, the part that comes after the coefficient has to look exactly the same. The part that comes after the coefficient must look exactly the same. Does that make sense? Now, these first ones, we're just going to be working with variables, so we're just looking for variables that are the same. If you have 10 of something and you take away 9 of them, what do you have? You have 1 of them. So we could put 1s. It's better just to put s because when the coefficient is 1, we don't usually write it. All right, so there we go. Look at that. Okay, now here you'll see I have not 2 terms but 3 terms. 3z plus 4 plus 4z. Now the 3z and the 4z are like terms because they have the same thing after the coefficient. They both have a z, right? 4 does not have a z on it. So I can put the 3z's together with the 4z's. 3 plus 4 is 7, and then I'm going to add 4. By the way, this is the reason why we studied those properties, because really what am I doing? I am using the commutative property to move the 4z over to the 3z. So I'm doing 3z plus 4z, which is 7z plus 4. Does that make sense? So that's why we had to study those properties, the associative property and the commutative property and the identity property. And very soon we're also going to be using the distributive property. All right, so let's skip up and see what they have at the next level. All right, now they've grouped them together, but you'll notice you can't add 6z and 3. They're not like terms. And you can't add 8z and 1, right? But we can use the commutative property and the associative property. So really what we're going to do, what we doing, man? What are we going to do? We're going to regroup. We're going to use the commutative property and the associative property, and this is what we're going to do. We're going to put the like terms together, right? These are like terms, and these are like terms. By the way, these are called constant terms. Constants are always like terms, right? Numbers are like terms with numbers. So what do I end up with? Well, this part right here gives me 14z, and this part right here gives me 4. And again, because those are not like terms, then you cannot combine those, right? So using those properties that I just mentioned, we get 14z plus 4. 14z plus 4. Does that make sense? I sure hope it does. Same idea here, right? 8k's plus 1 more k is going to give me 9k's. And I'm going to add that 1 and that 9, and I'm going to get 10. All right, let's skip up to the next level, see if it's any more difficult. All right, now it gets a little bit tricky because now I've got a subtraction here, but I have a subtraction outside the parentheses. So when we were adding, we could basically just work through the parentheses. They didn't matter because if that's addition, then everything's addition and the parentheses don't matter. But when you have subtraction, right? Let's think about this really quickly. All right? If I write that, what am I asking you to do? I'm asking you to subtract 7, right? If I write this, then the answer I get, minus 4 plus 3, is going to be what? Minus 1. Do you see how those are not equal? So when you have parentheses, you have to really do this. You have to subtract 4 and you have to subtract 3. That's what this is telling you to do. Take away 4 and take away 3. Now, normally we would just add 4 and 3, but see here, we can't combine those because they're not like terms. So what I'm going to do is I'm going to rewrite this as 7s plus 8, and then we call this distributing the subtraction. All right? And then I'm going to subtract 7s, and I'm going to subtract 7. Sometimes what you see them do is they will change subtracting to adding a -1, subtracting right there, and they do it like this, and then they distribute that -1, which gives us, in fact, the same result. All right, but I have found that students find it easier just to look at the idea of distributing the subtraction, right? When you have more than one term inside, don't subtract just the first one. Subtract, in this case, 2. Sometimes it could be 3 or 4 or 5 things. And now we are ready to combine our like terms, right? So now, again, using the associative and the commutative properties, this is going to become 7s minus 7s, right? And then it's going to be plus, what, 8 minus 7, right? I'm grouping the like terms together. Well, 7s minus 7s is 0, and 8 minus 7 is 1. And, of course, that just turns out to be an answer of 1. Okay? So when you have those subtraction outside the parentheses, it does get a little bit tricky. Okay, so now if you take a look, we've got several numbers here and just one with a variable. Remember, constants are always like terms. All right, so let's just do this mentally. 6 plus 10 is 16. 16 minus 6 gets us back to 10. And 10 minus 4 is 6. All right, so all of the numbers combined together give us 6. There's so many fun ways we could do that. We could do 6 minus 6, and we could say that's 0, and then 10 minus 4 is 6. We can group the minus 4 and the minus 6 together and get minus 10. Cancel with that. I'm having so much fun as a math teacher. All right, long story short, all right, and we usually put, if there's a variable term and a constant, we usually put the variable term first. All right, and then what did we have? We had plus 6, right? We had plus 6. So it's 10g, that's all. There was nothing to combine it with. And then we had plus 6 as our answer. All right, can we skip up to the challenge zone? Okay, remember how I said we were going to need the distributive property? Now, remember, when we are simplifying or evaluating an expression, we must remember order of operations. And what does that D stand for? It stands for division. What does that M stand for? It stands for multiplication, right? And remember, we do multiplication and division from left to right. All right, sometimes division is before multiplication, sometimes vice versa, but multiplication and division are always before addition and subtraction unless there's parentheses, right? So when we are distributing, that comes under the MD part of PEMDAS. It actually comes under the M part, right? Not the D part. And when we are combining like terms, that comes under the A and the S part. So what does that tell us? Distributing comes before combining like terms. Got it? So when I look at this problem right here, I'm going to have to distribute first, okay? And by the way, there's absolutely nothing wrong with using a calculator for these problems. I strongly encourage you to do it. Our focus is not the arithmetic, it is the algebra. Okay, so I'm going to do 2.2 times 1.3. Again, you should know how to do it without a calculator. You should, but that's not what we want to focus on right now. So I get 2.86. So I have 2.86s when I multiply that. And then I have minus, okay, then I'm going to do 2.2 times 1.3. And that one gives me, oh, Mr. Reeves, I wasn't even paying attention. They're the same number, you silly goose. All right. Okay, so I distributed 2.2. A positive times a positive is a positive. You could think of this as a positive times a negative is a negative. All right, plus 5.4. Again, that's not really a negative. That is subtraction, but subtracting a positive is the same as adding a negative. So it's just like that. Now I'm going to combine my like terms. These two right here are my like terms. So the first thing I did was I distributed. Now I'm going to work on my like terms. All right, so what do I need to do? I need to find the difference between these two. All right, remember when you're adding, you say, what do you have more of and how many more do I have? So again, this is minus, but we can think of this as adding a negative. So I have 5.40 positives and 2.86 negatives. So again, I'm going to go to my handy dandy calculator and I'm going to choose 5.40 and I'm going to subtract 2.86, and what do I get? I get 2.54. So this part right here is 2.5, excuse me, let's try that again. 2.54, and this part here was 2.86s. All right, so 2.86s plus 2.54. 2.86s plus 2.54. Survey says fantastic. All right. And on this one, again, I'm not going to go ahead and work through this one. You would distribute here, right? And then once you've distributed, write it all out and then combine like terms. So distribute, then combine like terms. Distribute, then combine like terms. All right. Okay. Let's go ahead and go to our next skill, which is R15, which we're doing very much the same thing now, except now they're going to throw in some exponents. Remember, like terms have the same variable or variables to the same power. All right, so again, whatever comes after the coefficient must be the same, and then they are like terms. So if you take a look at these are all like terms because they are all p to the second power. So what do I have? I have 8 of them minus 7 of them plus 1 of them. Well, 8 minus 7 is 1, and 1 plus 1, I'll give you a second to think about it, is 2, right? So then I'm going to do 2p, then I'm going to press that handy dandy button there and get 2p squared. Isn't that amazing? All right, what do I have here? I have 1t. Remember, if there's no coefficient written, it's a 1. I have 1t plus 4t's. What does that give me? It gives me 5t's, and I don't need this handy dandy button because there are no exponents. All right, again, all like terms. They're all f's. All right, 4f's, what a horrible report card. 4f's plus 7f's plus 2f's. 11 plus 2, 13f's. My goodness, 13f's on your report card. Not good. All right, let's skip up to the next level, see what they have there. All right, again, all like terms. Now we have a subtraction here, right? Well, 6 plus 8 is 14. 14 minus 4 is 10. And 10 plus 10 is 20. Again, we can combine them all because they all have m's. They are all like terms. All right, here we go. Now we have some that aren't like terms, right? That one there is going to be a like term with that one there. Now you notice that I highlighted the subtraction in front of it, right? Because it's not 10m plus 9m squared. This plus goes with the 8. So the operation the operation goes with the term that comes after it, all right? When there are no parentheses, that's how it's going to work. So I'm doing 10m squared minus 9m squared. And 10m squared minus 9m squared is going to be 1m squared. But I'm not going to put that 1 because we don't write 1 as a coefficient. And then what do I have? I have the plus 8 and the minus 6. All right? Well, what is a positive 8 minus 6? That's a positive 2 or plus 2. Look at that. All right, let's skip up to the next level. Really? Wow. Sometimes IXL doesn't make sense. This is not harder than the one we did. Again, all like terms. 4 plus 10 plus 3 plus 1. 14 plus 3 is 17 plus 1 is 18, and they are all the same like term of f to the second power, right? All righty. And now here again, same idea. Now it does get kind of tricky with subtractions. Remember, adding a negative is the same as subtracting a positive. Okay, so if you look at this, what do we have? This one, we have a positive 6w, correct? And then what do we have? We have a minus 5w. We have a minus 6w. We have a minus 10 that is not a like term. We have a minus 5w, and we have a minus 2w. Okay, so you see that? This is the only w term that is actually not being subtracted. All right, so if you put all these ones together, all right, again, I just want to remind you, subtracting a positive is the same as adding a negative. So sometimes we use those two interchangeably. Right? These two look different, don't they? Minus 5w and plus negative 6w, but the way I wrote them, it's all the same effect. We're putting a whole bunch of negative terms together. All right? So 5 plus 6 is 11. 11 plus 5 is 16. 16 plus 2 is 18. So what do we end up with? We have 18 negatives to 6 positive. Well, what does 6 take away 18? What does that give me? Negative 12w. So I get negative 12w minus 10. Negative 12w minus 10. Or negative 10 minus 12w. Either one of those will work. All right, so let's see if we can do this. All right, we have negative 12w, negative 12w, and then it was minus 10. All right, thank you for saying I'm wonderful. It is so nice when IXL builds up my self-esteem. All right, so we have here 10t plus 8s plus 2s, back to an easier one, right? Addition is usually easier than subtraction. All right, my like terms are the 8s and the 2s, so what do I end up with? 10t plus 10s. 10t plus 10s. All right, what about the challenge zone? We have, all right, they tried to make it harder, but remember what I said, the same variable or variables to the same power or powers. That's 10 of m to the third, n to the third. That's 10 m to the third, n to the third. These are exactly the same. What do you get when you subtract something from itself? You get 0. So they're like terms. I add the same amount, and I get 0 as my answer. All right? I can't believe this is the challenge zone. What a disappointment. 5st minus 5st. Those two, again, are like terms. Not only are they like terms, we have the same thing being subtracted, or if I change that to addition, they'd be opposite. That part is 0, and 0 plus 1 is just 1. All right. Oh, my goodness. I'm not even going to justify calling this being in the challenge zone. We're just back to where we were before, right? 8 positives plus 6 positives. That's 14 positive m's, right? And then I'm taking away 13 m's. So 14 m's minus 13 m's is 1 m. And there we go. All right, I am going to stop there. That is 2 skills, adding and subtracting like terms. We will be continuing by looking down here in our next video at linear expressions that are equivalent. All right, until next time. Bye.